Today we're going to talk about how to do polar coordinates. Before we start the question, we're going to talk about the definition of a vector. A vector is a quantity that has both size and direction. The length of a vector determines the magnitude of its distance. For example, the shorter vector is going to have a shorter distance because of its magnitude of its length. And obviously the longer distance has a longer magnitude. We also need to go over the units when doing polar coordinates. So we have the I hat first, which is the x direction and is horizontal. Then we have the j hat, which is the y direction and is vertical. And then lastly we have the k hat, which is z direction when we're doing 3D shapes. The key thing to remember when working with these units is it's only used to determine direction. Andy goes for a walk. He starts off traveling 15 meters west, labeled as vector A. He then makes a sharp turn, traveling 30 meters north, labeled vector B. After this, he makes another turn, traveling 45 meters, 30 degrees south of east, labeled as vector C. How far away is Andy from his starting point, labeled vector R? First, we need to add up the two easy vectors. We have vector A at 15 meters and vector B at 30 meters. Vector A is negative 15 I hat plus 0 j hat. It is negative because it's traveling in the left direction. Vector B is 0 I hat plus 30 j hat. It is positive because it is traveling in the upwards direction.
Next we will add vector C. This vector is a little more difficult because it is not completely vertical or horizontal. Vector C is 30 degrees south of east and has a magnitude of 45 meters. To find the horizontal and vertical component of vector C, you need to use a simple trick to find them. For the x component, you use cosine of 30 times 45, and for the y component, you use sine of 30 times 45. So for the x direction, it has a magnitude of 38.97 I hat, and for the y direction, it has a negative 22.5 j hat. It's negative because the vector is traveling downwards in the y direction. After putting the three vectors into directional units, you add the x directions together and the y directions together. For the x directions, we have negative 15 I hat plus 0 I hat plus 38.97 I hat, which equals a grand total of 23.97 I hat. For the y direction, we have 0 j hat plus 30 j hat minus 22.5 j hat equals 7.5 j hat. And then to find r, we use the Pythagorean theorem, which is r squared equals x squared plus y squared, and x equals the I hats and y equals the grand total of j hats. And to find r, you plug in 23.97 for x and 7.5 for y, and then you solve for r. So which makes a grand total of 25.12 meters for the vector of r. And then to find the angle at which you traveled from, you use tangent theta equals the y total over the x total, and the y total is your 7.5 and the x total is a 23.97. So then you plug your units in and use inverse tan to find that you traveled 17.37 degrees north of east. And Andy's net displacement is 25.12 meters and 17.37 degrees north of east.